This example, we have a word problem that we are going to find some sort of a maximum height, but let's read through the problem. It says a stone is launched vertically upward from a bridge 80 feet above the ground at a speed of 64 feet per second. Its height above the ground in t seconds after the launch is given by this function. So here's our gravity pulling it down. There's our initial velocity. There's our initial height. And we're going from 0 to 5 seconds. So when does the stone reach a maximum height? Right? So if you have a basic idea of what this, I always like to do a visual of some kind. We have an initial value at, let's say, 80, and this is not the path of the object. This is just the height with respect to time. So as time is elapsing, that's what's happening. So as time is moving on, the height comes up and then comes back down. So we're looking for that point right there, right? We're looking for whatever that maximum height is. And so back in an Algebra 1 or Algebra 2 course, or even a college algebra pre-calc course, we didn't have the calc to be able to do this. We would have found that that's the vertex, and we would have figured out what the vertex is in a little bit of a formula. But for what we have here is we can do the derivative and then set it equal to 0, right? Because I know that this is it. That's the only option that we're going to have. Right, so I'm just going to take this, do the derivative, which is going to be a negative 32t plus 64. And we're going to set that equal to 0. So negative 32t plus 64 is going to equal 0. If I solve that, I get negative 64. Well, basically, I can just plug in 2. That would make a negative 64 plus 64. So t is going to equal 2. So if we go through the whole process like we did on these other ones, that we have an interval, it's a guarantee we're going to get an absolute maximum and an absolute minimum. That if we did and started plugging in our values, we're going to do f of 0. We're going to do f of 2. That's a critical number. And then we're going to do our other side of our endpoint. And we're going to compare. Now, I promise you that that one is going to get us a maximum because I already have an idea of what's about to happen. If I plug in 0, everything goes away except for 80. If I take 2 and plug it in, I threw it into a calculator and it gave me 144. And if I plug 5 in, that gives me a 0. All right, so there is your absolute max. All right, and on any interval, you're guaranteed to get an absolute maximum and an absolute minimum. This is the absolute minimum. Here's an absolute maximum. So really, we were just doing this portion of the graph. So here's our 0, 80. Here is our 2, 144. And then here's our 5 with a height of 0. Right? And that's what we're looking for.